Fantastic. Okay. Thank you very much for coming. I'm competing for the people in person with beer and food, so I'm amazed that anyone has come. So, my name is Dale. I'm a developer for IBM. Apart from my day job of writing code, I'm really interested in STEM, in education, in helping out schools and code clubs in trying to introduce coding and technical subjects. So what I've got, the way this is going to work is, pre-COVID, I used to spend a lot of time going into schools, running code clubs, running IT lessons, coding lessons. And I've recorded some demos of projects that I've done in the classroom with kids, and I'm going to show you the demo and ramble a bit about, what the kids thought of it and what they learned from it. And the theme for all of the demos is around AI and machine learning. So, this is the first demo. It's from Mozilla. It's all about recruitment, the use of AI, the use of machine learning in recruitment. It's so in this thing that the kids have to look at someone's CV, the graph is like a representation of their CV, and decide if they want to accept this applicant or not. And they get really tight deadlines. They have to do it faster and faster, and then the thing starts sort of saying, well, why don't you train a machine learning model? And then it starts putting the machine learning model in charge of who's getting the jobs and who isn't. And they realize that, without realizing it, they put bias into it. And it starts getting the kids thinking about whether or not what we think of this sort of use of AI and machine learning and the impact of these unintended biases in these systems that affect our lives. It's a really fun game, really quick and simple, and it really makes the point really well. My next demo is Moral Machine from MIT. Now, if you know what I mean when I say the trolley problem, you'll know what this is about. Basically, the idea is that they have to make a decision of what a self-driving car should do. Something's gone wrong, there's about to be an accident, there's just a split second left to have one of two outcomes. Which one should it go for? And what happens is, similar to what you will be familiar with the trolley problem, if I skip on to the end, when you get to the end, it starts showing you what did you favor over others? And it gets the kids to start questioning some of the decisions they made, and also gets them thinking about what self-driving cars will mean and what it means to sort of try and impart our values into an AI. This one, I've only done it with groups that I know really well, because it's a little bit morbid as a topic. You're basically deciding what should the car kill. But it is a really nice way of explaining some of these issues. My next demo is Quick Draw from Google. This one is a really fun 5-minute activity. So if we finish a little early and I've got some time left of the class, basically it asks them to draw something, and then they have to try and draw it. And this is my attempts at drawing. And then when it recognizes it, it moves you on to the next one. And the kids are really, really impressed with how quickly a neural net is able to recognize their drawings. And if they get to the end of all of them, they can compare. It shows them why it sort of recognized, it sort of shows them what it's been trained with and shows them what other things it thought it could be. So like I say, really quick and simple, but it's a nice one to end a lesson with. My next one, also from Google, Teachable Machine. I really like this one. With this, it's a way of using TensorFlow.js to train a neural net in the browser. So with this, what we're doing is training it an image classifier using training examples we take with the webcam. So what you do is you put some object in front of the webcam. I'm using little Doctor Who Lego figures. And you hold it in front of the webcam and then press down that hold to record button. And as you hold it down, it keeps taking photos. You can get loads and loads of training examples really, really quickly. So then, you pick up the next Lego figure and hold it in front of the webcam, hold down the hold to record button, get loads and loads of examples. Before you know it, you've got a neural net. And if I skip to the end after I did it with quite a few, you can train it, and it all runs inside the browser, so the images don't leave the browser, which is quite a nice little touch. And then you've got, if I skip to the demo, you can test it, and you can see the output from the model in the bottom right there. So you see the confidence for each of the different classes. And that's just a nice way to let them, they can train their own model, see how it behaves, see what outputs it comes up with. An extension to this that we added was to take that model that someone can train in Teachable Machine, because another thing Google will let you do is you can host that TensorFlow model. You get free hosting on the cloud. So you click on upload, takes a sec, and then you've got a URL for where your TensorFlow model lives. So what we used is we extended a programming environment that schools use called Scratch, drag and drop sort of canvas-based programming, and we did some integration for TensorFlow models, including from Teachable Machine. And what this means is kids can use that model that they've trained in Teachable Machine in Scratch. Now this is not doing much more than the UI in Teachable Machine was doing. But you can imagine that, a more imaginative, creative student can come up with all sorts of games or animations, or, get it to make a TARDIS noise every time a certain doctor appears, or show the right TARDIS that goes with a different doctor. They can start making something with it, not just seeing the output and leaving it at that. Speaking of that page, machinelearningforkids.co.uk/pretrained, there's loads of other models that this can load into Scratch, including a ton of models that are already out the box. So some of them you've probably heard of. ImageNet is a really, really well-known image classifier. But we found a few others as well. So ImageNet, like I say, has been trained to recognize tons of different things. So you can load that pre-trained, ready to go into Scratch. You can see here the 1,000 and something or other different items that model has been trained to recognize, and it means with just a single block they can recognize different objects. So it's a nice way for them to start playing with quite sophisticated, mature machine learning models, but in a coding environment that they're already familiar with, because this is kind of standard used, at least in the UK, in primary schools. Another of the pre-trained models is the face recognition, and if you went to the deepfakes talk, which was in here earlier today, which was really, really good. One of the models they mentioned was face mesh, this idea of identifying landmarks on a face, so recognizing where a face is in a video feed and identifying where the eyes and nose and mouth are. Well, put that model that they were demoing earlier today into Scratch, the ability to find the coordinates of the eyes, nose, and mouth, and then you can do silly little things like this. It moves a mask to where the face is. Or you can do things like this, moving a few different sprites to where the face is. And again, it's more than just seeing the output from the machine learning model. It lets them make something with it. They can make games. They can make all sorts of fun projects and activities. Another interesting model is a question answering model. Now, this one's a little bit huge. It needs quite a fast computer to run, but if you can get it working, you can get it doing question answering. So you can get the text from a Wikipedia page of their choice, and then they can ask questions, and this machine learning model will look for answers to that question in the text that you give it. So here we were doing, I forget what the subject was for this one. Oh, it was Wimbledon tennis tournament. So you can ask it a question, what color are the tennis balls, and it will find the right answer in the page that you give it. So they can make something similar to what we demoed on a quiz show a few years ago, well, 10 years ago now, the Jeopardy system. But you can build that for yourself in Scratch, drag and drop blocks that a primary school kid can make for themselves, which is amazing. But the pre-trained models are fun, and they're nice to do something really quick and easy. But what I really like is where the kids train their own machine learning models, because when they train it for themselves from the ground up, they start to learn a lot more about how these technologies behave. They start to learn about how actually, I'll point out some of the lessons they learn as we go through the demos, actually. So this is the platform. It's where those pre-trained things were linked to that I was mentioning before, but machinelearningforkids.co.uk. The single biggest, that's my fault, I chose that URL. Ask a 7-year-old to type that in, it takes them forever. If I could start this whole project again, I would have picked a much shorter address. But anyway, the idea of this is they can log in so they can work on something week after week or in another lesson, but you can just use it without logging in. It's all project-based, so you create yourself a project based around a machine learning model, a model that can recognize text or pictures or numbers or sound recordings. And when you've created your project, it will take you through the 3 main phases of a project, starting with collecting your training data. So you create these training buckets. You give it a name, and you can create sort of several of them, but for here I'm just doing 2. And once you've created the buckets, you fill it with training examples. So you click on Add Example, you give it an example of what should go in that bucket, and then you're away. So the kids can create their own classifiers for whatever project they can dream up, whatever ideas they have, and primary school kids are amazingly creative. And then once they've trained their model, they can go into Scratch, and App Inventor is a way of doing drag and drop coding for Android phones, so they can make phone apps, or they can use Python. That's more popular with the secondary schools. And once you're in Scratch, similar to what I was showing you before with the pre-trained models, that model that they've created themselves shows up as new blocks for them to use. So they can, for example, collect new training examples. So they don't have to do it in the training UI. They can build the whole model from the ground up of collecting their training examples all in their Scratch project. So I'll do the, when you click on the green flag, add this training example, and that's it. So now, and to sort of prove that it works, if you go back to the training buckets, you'll see that new example in there. So this kind of gives them a really simple, friendly, guided way of doing all sorts of things, training text classifiers, image classifiers, speech recognition, sound classifiers, decision trees that recognize sets of numbers, all sorts of things, but in an environment that they're kind of familiar with. So that's just to show you what the tool is. Let's go through some things that they made. Actually, I'm going to skip this one. I might come back to it later. So this one is recognizing sets of numbers. The numbers here are coordinates. So what we did is we were looking at Pac-Man as the game. We only had one ghost in this, so Pac-Man and one ghost. So that's why there's two XY coordinates. The XY coordinates of Pac-Man and the XY coordinates of the ghost. And if I skip this on a bit to show you what I mean. So they played the game using the keyboard. So, they pressed the up, down, left, right arrows to control the little Pac-Man thing. And then every time they pressed a button to go up, down, left, or right, the current coordinates of the Pac-Man and the ghost used the add training block and added it into their training buckets. So basically, I told them that what they needed to do for the lesson was to play Pac-Man for the first 20 minutes. That went down really well. But once they played it, that's how all this training data got collected. They collected it by playing the game. And that's, I was saying, what sort of lessons do they pick up by going through these projects? That's a really nice one. In the real-world AI projects, we want to look for ways of collecting training data from things that people are already doing. So this is a really nice sort of lesson for them to learn. Oops. But once they've done this, once they've trained their machine learning model, what they have is a decision tree classifier that can make a decision when given the coordinates, what's the best decision for Pac-Man to do, to go up, down, left, or right. And then they can go into Scratch, put the AI in charge, and then watch it play itself using the training they've given it. And the nice thing is every kid is training their own one, so everyone will behave differently. And they'll get to see how their Pac-Man behaves, will play the way they played, and the kid sat next to them, their Pac-Man will play the way they played. Some of them will just do laps of the course, some will go up to the ghost and then run away, and they see all that happen. I'll come back to that one as well. Text is another good one. So simple text classifier, looking at like home assistants, things like Alexa, Google Home, that kind of thing. So they train the classifier to recognize the meaning of to the intent behind some text. So a couple of commands, turn this on, turn that on. They can add more, they can pick different devices, it's up to them. But with a handful of examples, and I found it sort of works after about like 5 or 6, they can train a model with that, go into Scratch, and then make some sort of virtual assistant. So here they've got something that they can give it a command. They can say, please turn the fan on for me, and then the fan comes on. Simple little thing, but the idea is to start showing them, because a lot of the kids will be familiar with Siri, be familiar with Alexa, they might have one at home or they might have seen one, but having made one for themselves, albeit a simplified one that has only learned 2 commands, but making it themselves, it starts to, they get that penny drop of, okay, what went into it, what was involved, and how do these things work? Text classifiers can do more than just recognizing the intent. This one I've done so many times. It's always a fun one. You basically ask a room full of kids to come up with the nicest, kindest compliments they can think of. None of them can ever think of any. And then the meanest, cruelest insults they can think of, and they can always come up with hundreds. And I've learned some new words doing this with kids. But what they do is they train a classifier to recognize the use of language in compliments as opposed to insults. And then they can make characters in Scratch that respond based on the use of language. I normally get them to draw their own characters, but my art sucks, so I'm just using emojis. But you can say something to the character, you're awesome, and then you make it look happy. Or you can say something mean and cruel to it, which they really enjoy, you dumb moron, and then you make it cry. And then the lesson almost always degenerates into they all try and make the thing cry by saying the most horrid things they can think of. I once did this as a live demo where I was in front of a room full of teenagers, and the idea was that, because we didn't have computers for them all to do it, so I was doing the typing and they were shouting out answers. So I said to a room full of teenagers, shout out insults at me. And you could see all the teachers looking at me like, what's he doing? Why would you do that? And they were right. Chatbots are another nice example. So get them to pick whatever topic they're doing in school at the moment. So this was about the moon. Come up with ideas of questions that people might ask, your frequently asked questions on your topic. Oops. And then train it to recognize a question so that when you ask it a question, if it's one of the frequently asked questions, the classifier will be able to recognize it. And then you can put that in Scratch to make a chatbot. So you can ask it, what's the average temperature on the moon, and it gives them an answer. It's a nice alternative. Instead of getting kids to do presentations or write a report on a topic, getting them to train a chatbot on the topic by doing the research to come up with the answer scripting, to think of the most commonly asked questions, to come up with lots of ways of asking the most commonly asked questions. It's actually a really nice way of sort of sneakily getting AI into a lesson. So I've seen schools, I've done this with schools where we did chatbot Romans, chatbot Vikings, we made a chatbot William Shakespeare. We did, what other ones did we do? I've done some chatbots about a school where you ask it about, for prospective parents to ask questions about. So this sort of activity can be customized massively to whatever the school is currently doing. This one is about looking at the use of language. So we picked the front page headline of a different national newspaper, and then trained a machine learning model to recognize the use of language. Some newspapers use capital letters, some use sentence case, some have very short headlines, a few words, some have really long, some have very emotive language, some are more factual. So the model picks up on that really, really quickly. So you can put in a new headline that the model hasn't ever seen, and then it will predict what newspaper that probably came from. And again, so I did this one with a secondary school that was doing media literacy. They were studying about the way different news outlets cover stories. So it was a nice way of sort of reflecting that in an AI session. Recommendation engines is another nice way of doing it. So here we're basically saying, what kind of hobbies and interests do people have, and where might they want to go, museum, fun fair, and so on. And then you can make a recommendation app. So you can actually do that in App Inventor if you want a real phone app, and that's where a lot of the kids would tend to do it. Or you can do it in Scratch like a pretend app. Say I want to relax, it will recommend the fishing pond. Say you want to do something exciting, it will recommend the fun fair, and so on. Sound models are really fun. So the kind of things you can do with this is similar to the way Alexa has a wake word. So it listens out for the word Alexa. So you can train a model to listen out for certain keywords, and they can do as many of them as they want. So what we did here is we trained it to recognize left or right, but to make it, we wanted something that an existing model wouldn't have. So what I said to the class was, this is an alien, you need to invent an alien language. So they had to invent some imaginary made-up word for left, blooble, flibble, and an imaginary made-up word for right. And then when they say that, the alien goes left or right, depending on what they said. And it's the kind of tech that goes into, like, say, the Alexa wake word, but they've trained it for themselves for a brand new word that they invented, so they know for a fact that the model didn't know that word out of the box. And then, the little alien moves back and forth. There's always some kids that are a little embarrassed saying some stupid made-up alien language. So this will also work if you do claps or click your fingers or shake some keys or whatever. Come up with two distinct noises. So some of them will do a clap and a finger click or something, and that still works. And again, it's still something they know they've trained. Other variations on that project, so here we did one where you came up with a secret spy code word for 3 different places, hotel, church, and stadium, and then we made a game where you would say your secret code word, and then the spy would go to the right venue based on what you heard. It's the exact same thing, just another sort of scenario for it. This one, I've just realized I forgot to plug sound in, so you won't be able to hear this, but this one is using a combination of the face mesh to see where your eyes are, and recognizing when she shouts out laser eyes, it finds where her eyes are, and then does laser eyes. So she has to shoot the bottles by moving her face to the right place and then shouting out laser eyes. It's very silly and very contrived, but you'll be surprised how much primary schools it gets very overexcited and silly, but fun. And this is bringing together 2 different machine learning models, a face recognition image classifier and the speech recognition one. And projects that bring together multiple machine learning models to do interesting things, I really love. Some really nice simple ones. This is an image classifier. So you can see when they create the buckets for image models, they can drag and drop photos from other web pages. So just open another browser next to it and then drag and drop images onto it. Or you can use the webcam to take your own pictures, or you can draw directly onto the canvas. So lots of ways of easily collecting training images. What we've got here is a load of images of 2 types of animal. Get the kids to pick anything they want. And then for this project, we were making a farm where we wanted to make an AI sheepdog that would get the animals into the right pen. And this was just a single lesson, so we kept it really nice and simple. Lots of photos of animals that the thing hasn't seen before, and they get put into the right place based on the model, what it's recognized. So the code, this is the entire code for it. It's something that a 9-year-old can do, and it is literally, if the image looks like a cow, move it to that coordinate, otherwise move it to that coordinate. Something we can do in a single lesson gets them familiar with what we mean by an image classifier. This one is using the webcam. So I mentioned, the webcam is a nice way of getting training data. So here is, they had to hold up a matching card. And with the classes, I have a bit more time. I get them to make their own cards. But for this, I'm just using printed ones. So they just have to hold it in front of the webcam and see how quickly they can do it. And you can get it to score it and get them to compete and that sort of stuff. But the nice idea is once you give them these basic building blocks and you just let them be creative and let them think of their own ideas, it is really cool what they can come up with. This one is, again, an image classifier, so using that webcam way of collecting training images. So 2 different types of image, one where they're not looking at the webcam, one where they are looking at the webcam. And then what we did was make a shy panda. So every time you look at the webcam, it gets shy and it stops dancing. That was sort of like the premise of it. So yeah, the idea is it sees her looking, it stops dancing. When she looks away, it starts dancing again. Very silly and contrived, but a chance to start to get familiar with what an image classifier can do. This one is using the drawing way of getting your training examples on. So I mentioned, you can draw directly onto an on-screen canvas. So I got the kids to draw some postcodes from some local towns and cities, or at least just the first bit of it. It keeps it brings the number of training examples you need down if you have only a few different options. So we made a postman pat game with a bunch of 7-year-olds where you draw a postcode onto an on-screen envelope, and then when you click on the stamp, it recognizes what you've drawn and sends the envelope to the right postman pat van. The nice thing about this is, it's a bit heavily simplified, but this is how sorting offices have automated the sorting of mail. So this idea that it sort of shows them a way that AI is used in real life is really, really cool. This one, I like this just because of, the phrase, judge a book by its cover. So we wanted to see, can an AI judge a book by its cover? Can an AI tell what type of book a book is based on a picture of its front cover? That was the entire premise. That was the only excuse of doing this project, but it was kind of cool. So get them to open up Amazon or a library website, drag and drop a load of books of a certain type into the buckets. And then, the machine learning model will pick up on patterns like the use of color, the use of fonts, and that sort of thing. So then you can make something in Scratch that when you show it, a book, it will work out what type of book that is. So you show it a music book it hasn't seen before, three blocks of code, it can tell that, that's a children's book, that's a music book, that's a cookery book, and so on. I've been sticking to Scratch for a lot of these examples, but like I said, all of these can be done in App Inventor, which means they can make mobile apps. And one example of that is using this Judge a Book. We made this like library app that will recommend what shelf you should put a book on based on showing it the cover of the book. So the idea is you put the book in front of the camera, take a picture of it, it uses that machine learning model they trained themselves, and then tells you at the bottom, 93% confidence, put that on the children's shelf, which is really cool. OK, 4 minutes left. I will make this my last demo. Scratch is a really, really heavily simplified interface. But once you start getting the idea, you can do some amazingly complicated things in Scratch. So this is that project I was talking about near the start. Lego figures, recognizing that that is the doctor. What you can see here is it's picking out the label and the confidence score and joining them together into a single string, which is what you're seeing here. What we were playing around with this was, if I cover up different parts of the image, what does that do to the confidence? So if I put that black square all the way up there, confidence hasn't really changed. If I put it there, the confidence has dropped like 40%. If I put it right over his chest, it's dropped around about, what, 12%, 10%, 20%? I can't do maths, 20%. So what can we infer from this about how significant, like we can infer from it that the top left corner, didn't have much to do with why the model thought that was the doctor. That wasn't very relevant. So if you take that and then just put that in a while block, so you stamp it every possible position on the webcam screen, and then Scratch has a nice way of letting you alter the transparency of an item. So you can make that. It's not a lot of code in Scratch, but what you've got is this sort of like almost heat map showing you what areas were the most significant in. Basically, we changed the transparency based on what difference it made to the confidence. So the more the difference in the confidence, the more transparent we make the square. And then we can do things like that. So actually, it starts to give us some insight into, well, why is the machine learning model recognizing this as the doctor? What parts of it has it picked up as being most important? So kids can do all sorts of really cool things about learning about how machine learning models behave in that sort of friendly environment. So with 2 minutes left, I will wrap up. So all of the projects I've shown on this Machine Learning for Kids section are available at this address, machinelearningforkids.co.uk/worksheets. What you'll find there is a PDF that you can download, and it's got step-by-step instructions. It tells kids, click here, then click here, then click here. They're also available as Word docs, so that's how, and teachers will quite commonly customize them. So I mentioned like the chatbots one. It means the teachers can tweak it and customize it for whatever topic they want to do it on, but there's like, these are a starting point. And as you can see, I haven't gone, there are dozens of worksheets there. I've only picked out a few for, to show you today. So that is the end of my talk. Thank you so much for listening. To recap, what I wanted to show you was there's a bunch of free tools out there to help you explain AI to kids. I showed you some from a bunch of companies like Mozilla and MIT and Google, but naturally, being from IBM and being responsible for the Machine Learning for Kids site, I spent most of my time showing you this one. But they are all awesome. Please go and give any of them a try. Thank you very much for listening. So how long does it take to do one of these projects? It varies. Like the images are definitely quicker. Kids are really slow at typing. So like the text classifiers, where they have to type in lots of examples, take a long time because kids do single finger typing. But the image ones, where they're using a webcam or where they're just dragging and dropping pictures, 45-minute lesson, you can train the model and make something in Scratch with it. So in a single lesson, they can do the whole thing. The text ones can get a lot slower. There are ways around that. You can get them to log into a shared project, and then so they all contribute training examples. So what I would do with young kids is instead of everyone create their own model, they do one for the class. Because if every one kid can type in one sentence, that's 30 sentences, and 30 sentences is enough to train a classifier. So yeah, it's data input is where the time goes. But understanding, trying it out, doing it, that doesn't take them long at all. So you can just see at the top there where it says project templates. So there's lots of existing free images in there they can start from. But you'd be amazed at how many the kids would say they don't want that and they'll draw their own. Like they want to, well, different kids get different things out of it. There's always the kids that like the coding side of things, but there's the creative ones that, like the chatbot thing, when they do it in groups, I've seen where the creative kids will spend ages drawing and animating their avatar that does the chatbot thing, and they don't get involved in the coding because they're not really into that. But there's some kids who are super into the research for the topic. So yeah, it varies hugely. But yeah, so I give a ton of images to help start kids off, but generally I see them use their own quite a lot. Yeah, I mean, because you can draw an image in Scratch from the webcam, what quite a lot of them will do is draw it on paper, hold it up, click the camera button as a really quick and simple way of getting their drawings into it. So that's really, really common. When they want to make a character in a game, they'll draw it out and then hold it up. Awesome. Thank you for coming. Hopefully there is some drinks and food left for you.